Oh, thank you. Okay, I just got informed. So my name is Edwin Robledo. I'm part of the Autodesk Fusion 360 team. Part of work with support, work with some marketing, creating some content. You may have seen some content contributed on the YouTube page by myself or by Jorge or by Richard. Richard has been hosting the German webinars this in the past couple of weeks. So I'm pretty sure if you have participated at all on our YouTube channel, you may be familiar with us. I started with Autodesk as part of an acquisition of Eagle, which was approximately, I think we just turned 4 years old now, Jorge, right? It's about 4 years now. This
Yep.
summer was 4 years.
That's
And
right.
so, you know, I've had the opportunity to be working with Eagle since the early 90s with Richard. As in the capacity of support, we would create some content. Richard did a lot of contributions to the manual. If you've been using Eagle at all, continues to do in that capacity with Eagle as well as with Fusion 360 as he works with that team as well. So my background, I'm here in South Florida. I've been in the communications world for a very long time before I actually came in over to CAD Soft Computer. And then for a little while there, we were with Farnell, which was Newark Electronics. And then in the last 4 years, we've been with Autodesk. And with Autodesk, the experience has been amazing. The implementations and the addition capacities to Fusion 360 and to Eagle have been amazing. So, and today we're going to be talking we're going to be talking primarily about electromechanical workflows. That's really gonna be what I'm gonna concentrate in this presentation today. But before we go there, I like to do some set some scenarios before we go there. So okay, okay, so when it comes to the design of any product, of virtually, if you're gonna put together a product that is gonna be going into the market, the design process has three key ingredients: collaboration, the design capabilities, and streamlining the process to update any design modifications. So imagine if you could get one application that could actually do all of this, and not only able to do it, but to do it well. Well, let's take a look at what are the current challenges that we're running into. Electromechanical challenges are effective collaboration. Right now, the collaboration capabilities that you may have if you're using multiple disciplines of engineering applications is email and phone calls, text messages, and so forth. Therefore, any type of modifications that need to be done, you need to create a third party type of communication streamline. You need to do file conversions. It's quite possible that you're using IGES files or step files or DXF files. You're exporting DXF files from the mechanical tool to the electronic tool. That way he could actually import them. Now, that really can open up the door for a whole bunch of errors. If depending of the type of team, of the different teams that you're working with, importing the DXF file can create errors because you may be using a unit system which is not compatible with the system that I have in my ECAD application as well. And as I export my step files for my entire design, now you need to interpret that on the mechanical side to be able to import that into your mechanical tool. Therefore, there's a lot of file conversions going along back and forth, therefore expanding the amount of time that is going to be used for the actual product. Now, in addition to that, we don't want to export a step file. We want to be able to work in a 3D environment that is truly functional, an environment in which the actual bodies of the components, the traces, actually the circuit board material is actually bodies in which they have been extruded, and I could actually make them function for any type of simulation. Well, what is that you need? The electromechanical workflow needs a design environment that meets both electrical and mechanical requirements for the product. Be confident that you're working with the most recent version of the electrical and the mechanical designs. And number three, quickly respond to changes made by other members of the team. What we need as engineers to solve this problem is a singular model that is collaborative, united, as well as intelligent. Therefore, the future of electromechanical design is here. It's here now, and it's called Fusion 360. Fusion 360 is a cloud-based CAD/CAM tool for collaborative product development that combines industrial design, mechanical engineering, machine tool programming, simulation, electronics, all into one software solution. Gone are the days of having to use multiple applications for the development of your next product. Learn one interface and use it with all these tools. Now, I'm not going to really be covering all those aspects of Fusion 360. I'm going to be reviewing and only the aspects of electronic capabilities and some of the possibilities of electromechanical workflows that we can do with the electronics capabilities of Fusion 360. Now, let's take a look at the electronic capabilities that Fusion 360 has to offer. Now, in the electronic side, and I'll be going live with Fusion 360 in a minute and demonstrating this as well, we have multiple editors. The schematic editor does have a SPICE simulation capability. Therefore, you could assign SPICE models to your components and actually simulate it. And the best part is that we have true annotation between the schematic and the circuit board. Now, if I move over to the circuit board, we have annotation between the circuit board as well as the schematic. What does this mean to you? True unification. In other words, modifications done to the schematic will actually update the board. There's some modifications that I could actually do on the circuit board that will actually update the board. They're collaborating, they're tied, and they're constantly making changes to each other, making sure that any updates, if you change a component, if you change a connection, that the other editor actually takes that into action as well. So the PCB editor annotates with our schematic. The team has concentrated in some amazing, amazing tools when it comes to manual routing. Okay, and those are webinars which I've been already hosted. Jorge actually has done some manual routing capabilities. And if you go to the playlist on our YouTube page, if you go to the playlist, I've done some overview about all the manual routing capabilities, such as quick route routing with guided for multiple signals, and many other ones that we have. So if you visit the YouTube page, I've actually done quite a bit of demonstrations on those capabilities as well. Okay, and the nice thing is that not only does the PCB annotate with the schematic, it actually annotates with the circuit, with the 3D PCB. And we're going to be talking a little bit further about the 3D PCB in just a few minutes. We got to cover that because the 3D PCB is going to be key. It's going to be the nucleus of our electromechanical workflows as we go again. Okay, now, what is a good circuit board application without a really, really good, easy to use library editor? Well, guess what? Fusion 360 does include an electronic component library editor. This library editor couldn't get any easier. It actually includes an IPC compliant generator, but it extends its capabilities over above only IPC compliant components, okay? So you could actually select a template, just transfer the data from the manufacturer specification sheet, and you'll get the footprint as well as a 3D model done in one setting. In addition to that, soon you'll be able to actually add the material details of each one of the components. That way, when you're going to do any type of e-cooling simulation, that will be, you'll get some true results as well. And third but not least, and I left this last just because it's going to be the center of everything we're going to be discussing today, is the 3D PCB editor. Now, the PCB editor, the 3D, actually works in conjunction with the PCB editor. In other words, modifications done to the PCB, to the circuit board, the 2D layout, will actually push those changes to the board, to the 3D. But you know what? I could actually mirror components or move components in the 3D, and that will actually take effect in the PCB layout as well. And we're going to be doing some simple demonstrations, and I kept it simple just for sake of time, okay? Now, we need to understand about workflows. We need to get an idea of what are the workflows that the possibility. When you're going to start working with a product or you're going to start working with a team, you got to really consider what are the workflows you're going to be using. How are you going to go about it? Who's going to be driving this design? Now, there's a couple options here. Now, the design could be driven by what? It could be driven by the circuit board requirements. So the circuit board, depending on the complexity of the circuit board or the physical aspects of the circuit board, it could be because of heat, it could be because of the components being used, it needs to drive the enclosure. So that's one of the workflows that we are able to do. Now, there are times that the geometry of the enclosure has to drive the circuit board layout outline, the geometry of the PCB. And this is where our paradigm shift is really, really good at, because we are now able to really, truly just capture the circuit board out. We could really capture the enclosure outline if necessary, and all the details like any type of holes that are going to be on that outline, the geometry of the outline. We could actually capture that and bring that over to the bring that all the way over to the circuit board. That way, the electronic engineer is certain that he's actually using the layout that he needs to do, because it is the driving force is the enclosure geometry. Now, there'll be times that you got to be flexible. Both guys need to be able to do changes. It's quite possible that the circuit board design needs to make some modifications, and the enclosure needs to make some modifications. And that is one that we also have. It's and it needs to be an adjustment, and that's where communication between both disciplines, mechanical and electronic, we'll have to be using our common capabilities on Fusion 360, okay? And I'll try to reach that point if I'm able to. Now, let's talk a little bit about these workflows. I'm going to go through some slides, just that way we could just have an idea. Now, what I want you to understand, is that the nucleus of our electromechanical workflow, for it to work, is our 3D PCB. If you look at my slide, that's why I have it there on the center, the 3D PCB. In other words, I could push from my circuit board to a 3D PCB, and I could insert that in an enclosure. Or I could actually capture the enclosure geometry, create that 3D PCB, and then have that turn into my geometry for my circuit board. So what I'm trying to say is that the nucleus, what puts it all together, our electromechanical workflows, is the 3D PCB. That's what is truly, that's how it really works. So you're going to be seeing our webinars and any type of demonstrations that we do. We're going to be making a lot of reference to the 3D PCB, because that's what it puts it all together. Okay, and all these workflows come together based on the 3D PCB. The 3D PCB is I like the way Jorge describes it. It's the glue that joins our mechanical and our circuit board layout capabilities. Now, let's talk about one of the workflows. Now, and this is the one that we've had ever since Fusion 360 has electromechanical capabilities, is to create the PCB. The create PCB allows you to either capture sketch profiles in the design workspace of Fusion 360. If you have an enclosure, it lets you capture the sketch profiles on the enclosure, and then once you capture it, that will take that to the 3D PCB. It will take that geometry, that selected sketch profile geometry, it will be taken into the 3D PCB, which I could then absorb that in my PCB layout as well. Okay, now this one was actually added not too long ago, PCB Derive. And this is actually, I think if you're working on a product that really is going to be going inside of an enclosure, it's quite possible. Jorge, you let me know if I'm wrong, but I really feel that PCB Derive might be the one that is most commonly used. What do you think, Jorge? Hey, Richard, what do you guys think? I really feel that that's the one that might be used as much. What do you think, Jorge?
I think if the enclosure is what's taking the lead, in other words, you have a prefabricated enclosure or something you have to conform to, then this will be the way to go. If there's more flexibility, then maybe you can start with the PCB and have that dictate the enclosure. But these days, most people buy enclosures, so probably this will be the most common.
Yeah, so there's means by which enclosures are now available to the public that, like, I think we refer to them as off-the-shelf enclosures. So we could actually just buy an off-the-shelf, and a lot of times you're going to be doing this for prototyping. But then again, this changes quite a bit, because since 3D printers are so accessible, if you're prototyping, then you could actually just go ahead and 3D print. And one of the nice things is that Fusion 360 will actually give you the capability of actually 3D printing your enclosure. And you could actually even 3D print your circuit board if you wanted to, for that matter. That way you make sure that everything fits as well. Okay, but that's another webinar for another day. Okay, now the PCB derived, what's one of the main characteristics? Main characteristic is, as Jorge already mentioned, it's going to be driving the circuit board. Now, when I use PCB derived and I capture and I select the geometry profile that I want to use, it actually makes it inaccessible on the circuit board layout to the PCB designer. Doesn't really truly make it inaccessible, but it actually locks them down. It locks any geometry selected as going to be used as a geometry is going to be locked down. In other words, the user cannot really make modifications. The electronic engineer using the PCB layout can't really change it. It's going to be all locked, and he should leave it locked. If he starts making modifications, things could get a little complicated. So any changes that he needs to done to the PCB layout, if they were necessary, he should actually communicate that to the mechanical engineer and to let him actually make the modifications, because he's leading the geometry of the layout at this moment. Okay. Now, oh, okay, yeah. Hey, yeah, Richard just mentioned if you have questions, go ahead and use the chat. It's always a really good idea, and I'll try to address them, or the guys will let me know if I need to, if I need to address them while I'm working here. Now, one of the third one was actually just pushing the circuit board to a 3D model. And then from there, I could insert that 3D PCB into a design workspace, and then I could just design an enclosure around that if necessary. So that's actually one possibility. So I could actually just push my 3D PCB push my circuit board to the 3D PCB, and then from there I could go ahead and insert that in a design workspace. And then, yes, I could project the surfaces of the circuit board and create an enclosure around that if necessary. Okay, so let's go ahead and move on here. So I think this is my last slide. Yes, it is. And let's go ahead and move on over to Fusion 360. That way we could take a look at what we're explaining here. Just to let you know, I am working on a Mac, but if you're working on a Windows-based machine, it should work exactly the same. There should be absolutely no difference. One thing I wanted to bring to your attention is we've been talking about communication or collaboration. Okay, first of all, when it comes to being able to stay in tune with your team, in Fusion 360, you're going to notice, and this is the design workspace of Fusion 360, just to let you know. This is one of the primary mechanical design workspaces in Fusion 360. Down in the bottom here, on the bottom left-hand corner, well, at least it's mine in the bottom corner, is where we have our comments here. When you already are working in a design workspace, you could actually start adding comments to it, and anybody that's a member of this design workspace will actually be able to see those comments, okay, and reply to the comments if necessary. Now, let's go ahead and take a quick look at the data panel really quick here. The data panel is how you're going to structure where you're going to store your information. And the collaborative is really easy. First of all, there's a requirement that everybody that you want to collaborate with on your project, whether it's electronics or mechanical, need to have a free Autodesk account. It's primary. That's number one. So if you go here where it says people, you could start adding the email addresses of those that you want them to be joining your, and click invite. If that person already has worked with their account, they're going to be receiving an email letting them know that I've made them part of this design. I've made them part of this project folder. Okay, so here's our data. Now, how do you access the electronic design workspace? On the file pull down menu, I'm just going to close this data panel for this time being, yes, for sake of space here. To get to the electronic design workspace, I'm going to click on the down arrow over here where it says file. and you're gonna go right here where it says electronic design. This is gonna open up what we refer to as an electronic document. From the electronic document, I could actually create my first schematic, and then I could create my circuit board. Usually you create your schematic, and from the schematic, you actually create the circuit board. So unless you have Eagle, you've been using Eagle, I know we have some Eagle users in the class today. If you already have some Eagle files already made, and you wish to use them in Fusion 360, the first step you should do is actually create a document, and then click here where it says reference a schematic document, and then click on select computer and navigate through your computer to find that and select that schematic and load it up. Then follow the exact same steps with the circuit board. Click on the link here, click on select computer and navigate your hard drive and bring in that circuit board as well. And in the electronic document, if they're actually consistent, they will actually start working together. It's very important that you always work from the electronic document, because that is what actually keeps annotation between the schematic and the circuit board, and eventually to the 3D PCB as well. Okay, now, so let me close here. I already have an electronic document started. Let me move this out of the way here. The dash, I get the dashboard out of the way. Now, I already have an electronic document already created, and you'll see it right here. On the electronic document, as you could see, I could use it as a preview. I could actually preview my schematic, and I could preview my circuit board. If I actually had a 3D PCB attached to this, I could see those as well. If you had multiple schematic sheets for this design, I could actually just go here and expand the schematic, and I'll see all the sheets here. So you could actually use it as a viewer as well. Now let's go ahead and move over to the schematic editor. Now, yes, as I showed you earlier on the design workspace, you know, let me bring back. As you could see, we have our icons, the primary icons, the most commonly used icons on the top. This is the design workspace. Then you have multiple tabs up on top. Depending on which tab you have open, will change the environment of the icons on the bottom left. So the toolbar changes depending on which tab you actually have selected. I wanted to bring this up because now let's go take a look at what the schematic is. On the schematic editor, you'll notice that we have the exact same interface. We're using the exact same interface. Of course, there's some modifications, you know, to accommodate what is electronic design. As you could see, you have the tabs up on top, and then you have the icons the most commonly used. Now, usually the first set of icons will not change, okay? They'll not change. Those will stay stationary while the other ones will change to accommodate the different tabs that you have selected, as you see here. Okay, now when you're adding components to schematic, we actually have a really, really long list of available components, which are contributed by us, and they're actually contributed by manufacturers and distributors of components. So if I go ahead and I click here, and the only reason I'm addressing this question is because I saw in the chat that somebody was talking about some integrations, and the process has sort of started. And this, we click here where it says add part. Okay, and I had done some searches earlier, so let me just go ahead and change this a little bit. Okay, these are some of the default libraries that actually come with Fusion 360 as well. And you'll notice that who created the library, the ones called Eagle PCB were actually created by our team, as well as the ones called Fusion Electronics. There are some that are, and those are the other ones that are created by our team of librarians. Now, if you want to access further libraries, before I actually go there, if you expand the library, okay, and you see this little icon here where it has like a little chip there. If I select that icon, that means that there's a 3D model assigned to it. So just want to let you know that way you can see that. There means that there's actually a 3D model assigned to that component, okay? So if we go here, the caps, and I expand my CUS, you'll see that we have 3D models assigned to this. So that means that if I use these components, when I render the 3D PCB, I will get 3D models. So we have some other legacy libraries that we're adding more and more 3D models to them, but you'll find some libraries still don't have 3D models assigned to them as of yet, okay? Now, there are many more libraries more than just this. If I click here down bottom where it says Open Library Manager, I click on Library Manager, just give it a minute. It's going to let me know what designs I actually have. This here, the first tab, is just letting me know what libraries are currently I'm using in my design. If I go in use is basically the same list that I have here. So these are all the libraries I have in use, which are these libraries as well. These are all the libraries I have in use, okay? Now, if I need other libraries, if I want to access further libraries, just go ahead to go to the Available tab. Here you'll notice that when it has this little icon to the left of the name, it means that it has not been downloaded, okay? So you'll see, and these are the author of these libraries, or the company that is managing this library. These are by Eagle PCB, which is our team of librarians. If I scroll down, you'll get some by PCB Layout. Worth Electronic has a huge repository of components available. And when you see this little circle icon right next to the name of the library, this library, apparently I already have it in use, or I use it at some point, but that little icon, and if I don't have the little download symbol and I don't have it in use, it just means that it's possible that I have it cached. So if I was to put it in use, it would come in already really fast. But that little circle means that the author of this library actually has made modifications to the library. So it's, I get the updates. If you were to just go ahead and select the library, and you could select over here on the right-hand side, the update capability right there, it says update. That way you could get that latest version of that library, okay? If there's any of these libraries that you're interested in using, just go ahead and select the library itself, and you you would select use to actually get that library in use, okay? And that's how you put that library in use. That way you could use it in your design. Now, once the library is actually in use, I'm just gonna go ahead and make a connection, really quick connection here. I'm gonna just click on net. That's the command is called net. If you get really close to the components, you notice that when I get close to the connecting point, I get that little bubble. That's letting me know that that's the connecting point. I could just go ahead and click here, select this net. I'll go to there and go right there. As I reach my destination, I get my connection right there. If I click there, it completes the connection. Now, if I actually want to create the circuit board based on this, the first thing you should always do is save. Okay, and I'll go ahead and build my circuit board. I think I actually have. Okay, here we go. So this is the default load that what's going to happen. So you're going to always end up with all your components off to the left-hand side of the circuit board. And now I'm just going to just use the, actually you don't have to invoke the move command. You can if you want to. I'm just going to group these components real quick and select right here in the middle and just move them in here. I'm right-clicking to select the, and I'll click OK. And let's go ahead and save what we've done so far. I like saving from the electronic document because it cascades that name all throughout. Now, you don't have to do it this way. It's not necessary. You don't have to do it this way. I just like cascading throughout the from here. That way it cascades out. But nice thing is, please notice an observation that I want to do is the versioning. You'll notice that my electronic document, my schematic, and my board layout, depending on how I've been saving, if anybody else, let's say Jorge, which is collaborating with this, every time he saves, it's going to make a new version. Either he's working on the schematic, and Richard is working on the circuit board. These version is going to actually change. So these versions will change depending on who's doing the save, or it's me or anybody in our team. Now, to be able to promote, let's say, for example, I didn't like the changes that they did, or I actually want to go back to an earlier version because we're going to be producing that product one more time, you'll notice that there's version options right here on the data panel next to the, let's say, the schematic, for example, right here. And I only have 2 of them right now because I just started this project. It gives me the time frame, and it'll let me know who's the author, who's the person that actually made the changes. You could actually select one of them, click on these little 3 dots right here, and you could actually promote that if necessary, okay? Now, I wanted to just bring that up really quick. Now that we have the circuit board I already created, now I'm going to go ahead and push this to a 3D PCB. That way you could see some really nice capabilities that we have there. Now in this scenario, the circuit board is kind of taking the lead on the PCB editor. So I'm going to go ahead and click right here where it says View in 3D PCB. Please remember that I told you earlier that the 3D PCB is the nucleus of our electromechanical design capabilities between the design workspace and the the design workspace and the PCB layout editor. As you can see, here's my board layout in 3D PCB. Now, one quick observation, I'm just going to save this really quick. Okay, call it 3D PCB really quick. And you see here, I actually did the mistake of actually adding this part here. And I did the mistake of the USB is looking the wrong way, for example. I could actually just go ahead and grab that component right here. I could turn it around. Every time we demonstrate that to the mechanical engineers, they kind of love it. Now, if this had any routing involved here, I could actually select the option, update the PCB. And if there was any routing involved, I could tell it to update the routing as well. Okay. In this case, I'm going to just tell it to update the PCB. Okay. And I'm going to go ahead and click OK. Now what's going to do is it's going to handshake between the circuit board, the PCB layout, and the 3D PCB. It's going to go back and forth for a few seconds, and you'll notice that now the pad leads where you solder onto are actually now at the right place. Now, if we go over to the circuit board, you will notice that now that has been changed as well. It actually flipped that component. Now, if this was a bit more dense of a component, and I actually wanted to create an enclosure for it, I could just go ahead and I'm going to save what I've done. I like saving just in case I need to recover at any point. It's got that bad habit of saving. Okay. Now, I'm going to open up a design workspace. I'll give it a name. Call it example 1. Okay. And then now I could go ahead and insert my 3D PCB into the design workspace. Okay, so here's the 3D PCB that we created a few minutes ago. I could kind of move it around. I'm just going to leave it as is right there. And then around, if required, I could just go ahead and say, you know what, I want to create an enclosure for this really quick. So I could select which place, what face I want to do it on. Go this way. And do this. Outside 3. Okay. So there you go. So if you needed to, you could easily create an enclosure based on the circuit board, as you could see. Once I have the circuit board in my design workspace, I could actually just capture the circuit board outline, the geometry of it, and create my enclosure around that. So this is one of the examples. This is one of the most simple examples I wanted to cover today before we actually run out of time. Now let's talk about what Jorge had said that is going to be the most common workflow, is actually working from the geometry of the enclosure over to the PCB layout. And let's see how that works, okay? So let's go ahead and I'm going to close what I've done so far here. Now I'm going to return to my circuit board. I'm going to close this here to my original circuit board that I've been using. And I'm going to break the link with my 3D PCB. That way I could use that same example one more time. Now, I have an existing enclosure. Let's say we got an existing enclosure and we have the DXF file for it. Like if you use the MagMaster catalog that comes with Fusion 360, you'll be able to find some enclosures available in there. And this is the method that you would use to actually capture that enclosure and adapt it to your circuit board. Okay, this is going to be one of them. Okay. So what I'm going to do now is I'm gonna create a sketch profile. It's always works better if you create a sketch profile. So I'm gonna go ahead and select create a sketch, and I'm gonna be doing that sketch on top of this profile right here that we have here. Okay, that's the plane that I'm gonna be using for my profile, and I'm gonna capture the inner workings of this enclosure. That way I get the measurements from it. So I'm gonna go ahead and select this corner here, this corner there, and this corner there, and the one on the bottom. Now I want those holes to come over as well. The holes that I'm going to be using for my bosses, I actually want to select these here as well. Okay, and then go ahead and click OK. Now I'm going to select, I'm going to finish my sketch. I'm going to click on Create PCB. Okay, I'm going to select that outer sketch that we already created. And since I want these holes to show up on my circuit board, I'm going to select these bodies here as well. Not sure why those other ones are not coming through. Maybe I'm too far away to select those. Okay. I'm going to go ahead and click OK. And there's my circuit board. Now, this is the circuit board that I created based on the enclosure that I had. Okay. Now, as you see, this is my circuit board outline. Now, I want to apply this circuit board outline to my PCB. I want to apply this 3D PCB. I want to apply this 3D PCB, this 3D here. I want to apply it to my circuit board, which is this one. Now, this one, if you notice, this is my circuit board. You see the outline? There's no holes here because there's no association yet. So I'm going to, that captured enclosure that I did earlier, I'm going to link it to that circuit board. So I'm going to click here where it says link to 2D PCB, as you see. And then I'm going to go right here, select this one right here where it says webinar. I think this is the one that I'm using. And I'm going to go ahead and click on select. Okay. Once I do that, now you'll see that the outline of the geometry of my board outline has changed, and the holes that this PCB is going to be mounted transferred over as well. Okay. Now, by using this method, I can make modifications to the outline if necessary. Okay. So let me save what I've done so far. And to finish the synchronization, as you see, you get this warning sign here where it says your 3D and your PCB, your 2D and your PCB are out of sync. Since we actually adopted that geometry, I need to push it back to the 3D PCB to complete the cycle, as you see here. So I'm going to push the 3D PCB, as you see here. Give it a second. And there you go. Now we have our solder mask, we have our holes, and we have our components. Okay, so this is using PCB Create, as you see. Now, I can make changes on the circuit board here, and those changes will actually take place here. Now, inserting this in the enclosure, it could be done, and I'll show that to you really quick. So let me just go ahead and save what I've completed so far. Okay. I'm gonna make a duplicate of this enclosure. I'll go ahead and copy. So there's a duplicate of the original enclosure, and now you would be able to go ahead and insert the 3D PCB into that now as well. Insert that into there. And once it's inserted, you will have to do some fine-tune lining up on here as well, as you see. So just line that up correctly. You could use joints or anything like that to go ahead and line it up for you. Okay, let's go here, there, and there it is, lined up. Now you could go ahead and start working on the enclosure. That way you make sure that that the enclosure meets the criteria of the circuit board and vice versa. Now, let's say what we've accomplished so far. We're using PCB Create so far. Now, what I'm going to do now is I'm going to use one of the latest tools I got added to Fusion 360. Actually, it's been added for a while, but we've taken advantage of it on the circuit board layout. It's called Edit in Place. Now, I'm actually able to make changes in the circuit board and see it in the design workspace. I could actually make changes in the design workspace and see those changes on my PCB. You'll notice here where it says, this is where I linked. When I inserted my circuit board into the enclosure, you see right here where it says link. I could select here where it says edit in place. Okay, give it a second. It takes a minute. It's going to tell you that it's going to be an associated edit in place. There's an option to not be associated. Not sure when you would actually use that one. I like using the associated always. I'm going to go ahead and click OK. Okay, and notice that now we've kept the enclosure, as you could see here. We've actually kept the enclosure. But now we have the 3D PCB editing capabilities actually showed up in our toolbar. I could actually select one of the components. I could select here the component. I could actually select this part, move it. Say if I wanted it over here, that I'll click OK. Now, what you need to do is that you need to save this part. Okay, this actually needs to be saved. Okay. First of all, we need to finish the edit in place. You see here up on top. When we invoke the edit in place, let's invoke this little toolbar that we have here. We need to just end the edit in place. Okay, let's save what we accomplished so far. Okay. Now we're going to go to the 3D PCB because we changed this USB here that we see here. We actually we modified its location. Now here is where it gets a little tricky for us right now. And we're working on getting this fixed when it comes to edit in place. But I felt that this feature was important enough to demonstrate, even though we need to get some work done. But in this, you need to actually close it, the 3D PCB. You actually need to close it. And then we will go ahead and open it up again. Once we open it up again, you'll notice that the version actually changes, and the circuit board now has, the 3D PCB has the new location of the USB, okay? With the new location, and it lets me know that it's out of sync with my circuit board. Okay, so if we take a look at the circuit board, you will notice that the USB still has its original placement. So if I go over here to the 3D PCB, and we're gonna go ahead and synchronize that, and it gives you a notification. I'm gonna select here where it says push to 2D PCB. I'm gonna go ahead and push it. You'll notice that it actually is adopted. As you see, it moved it, and to finish the synchronization, I'm just gonna go ahead and push it back. And that's how you do edit in place, okay? And this will work it doesn't matter which workflow you do, the edit in place, that's the way it works. So as you could see, now we have full synchronization between our circuit board as well as our 2D PCB. Now, if I make changes to the component, let's say if I make the changes here on the circuit board, I'll just go ahead and close this here real quick. And I'm gonna move these parts I have here. For example, if the electronic engineer needs to make modifications to the circuit board for X or Y reason, let's say he's changing a component, the component gets too hot, so he needs to find a different location. So I'm gonna go ahead and move this part here as well. I'll move the component, I'll just move 2 components here, and I'll click OK, and I'm gonna go ahead and save what I've accomplished so far. Okay, and I'll go ahead and push these changes to our 3D PCB. You'll see that my components now have the new locations. Now now go ahead and save. Every time you see this asterisk here on your 3D and on anything, we refer to it a lot of times as a dirty file. It just needs to be saved. So you just go ahead and save it. Now, I'm going to go ahead and go to our enclosure. And look, you'll notice that we have some triggers here. it's been, you have these triggers, these yellow triggers has showed up. Okay. Those yellow triggers is just letting you know that there's some changes that have been done to the layout that have not been adopted here. So to be able to accept them, I'm just going to go ahead and click on those warning signs. And you'll notice that not only did it actually accommodate the USB, now it moved the landings for the USB, but it actually now updated the IC1 and the U1 that I had as well. Okay. Now, what's different with the other electromechanical workflows that we have is that I could actually capture the enclosure, but this time I could capture the enclosure using what we refer to as PCB derived PCB from Sketch. Now, using this method is, and I'll use this really quick. See how quick I could do this, because I know we're very short on time. So I'm just going to go ahead and change this and select this body that I have here. See if I could select this body here. Leave that one there. Grab that one. Okay. Now, I'll click on select. Now, when you're using PCB derived, you remember, every time you're working with the 3D PCB, you're going to get this notifications that we need to finish the synchronization. But one thing I wanted to bring up here is I'm going to just go ahead and highlight on the filter, the dimension layer, and select the dimension layer. The dimension layer defines your board outline. Notice that it's locked. So when you use PCB derived, you're going to notice that your outline is locked. Therefore, the idea here is for the electronic engineer not to really have the capability of actually making modifications to the outline. Okay, he could work on the circuit board, but we really want the mechanical engineer to make any modifications to it here. So now let's go ahead and push back to our 3D PCB real quick. That way we could get full synchronization. It's just letting me know, hey, you know, I'm only going to make changes to the parts that you have, because it identified it as a derived PCB. So it's only going to take into consideration the parts. And I'm going to say yes. If you say no, things get it's a little bit different. But you should always just say, yeah, I only want to make changes to the outline. Now, since this enclosure, the geometry of this PCB outline was based on by projecting the geometry of an enclosure. Let's see what are the capabilities, what changes, and it's actually pretty neat what we could do now. So let me, as always, I always like saving before I continue. And we have 1 more minute, and I'll finish this and open up the platform for any type of questions you may have. Now, here's the difference with PCB derived. This enclosure, I actually created it. I created this enclosure based on a sketch, right? So I'm going to edit my sketch. Edit sketch. Click finish. You see now it adopted the new contour. If you see that it adopted the new contour, let's save what we accomplished so far. And once we save, now when we go to 3D PCB, it gives us the warning. Okay, and there it adopted the changes. Okay, apparently I got it right this time. Now I could push this over to my 3D PCB and go back to that whole cycle between the 2D and the 3D PCB. Thank you for joining us. Have a great day.